Hello and welcome. Today we are going to cover an extension of factoring, which is using the zero product property. So we're going to learn how to solve a quadratic equation by factoring. Now, first thing is, of course, make sure you have your notes in front of you. I do have notes at the very top talking about the zero product property. But let's go ahead and jump into it here. Okay, so the zero product property quite literally says that if I have two products. So I have A, I have B. They are being multiplied, so AB is multiplication. And this is equal to 0. So if AB equals 0, then either A is 0 or B is 0. But we're not quite sure which one because they are variable values. So we would say literally either A is 0 or B is 0 if we were to write it all the way out. Now, if you're working in a problem, you have to kind of go a little bit further with it. So for example, let's say I have x minus 5, our first example on the page, and I'm multiplying against 2x plus 7, and this is equal to 0. Effectively, I have a product. I have one term, this is, if you think of it, A. I have another term, this is B. Because they are in a product, they are being multiplied here, I can technically say either x minus 5 equals 0 or 2x plus 7 equals 0. And either one could be true. We're not quite sure which one is which, so we have to assume that both are true. Now, here's what we're going to do. These are not simplified, so we're just going to go ahead and simplify. Have we done the zero product property? From this stage to this stage, absolutely. All you're doing is you're saying that the products equal 0. And so you set those up as the individual products are equal to 0. And then from here, simplify. You know how to do the simplification at this point. So let's just jump through it. This one, just add the 5. So either x is 5 or we subtract 7, divide by 2, x will be a negative 7 halves. And writing it just like this is perfectly fine. Or you can combine it where you say x is equal to a negative 7 halves, comma 5. Always go least to greatest. It's more of a formatting thing. It's not a requirement, but always go least to greatest as you're writing your responses together. And that's it. That is the whole concept of solving a quadratic equation by factoring. But to get here, you have to have your quadratic equation factored. So let's do a little practice. Let's say I have a problem. X squared minus 9x minus 22 is equal to 0. As it is right now, this particular trinomial, this quadratic, is not factored. So I have to do a little bit of work here. I have to factor this down. So again, this is a trinomial. You look for a greatest common factor. I don't see one. Because it is a trinomial, it's 3 terms, that means I have 3 different options. I can use box, guess and check, or the AC method. This one looks like it's probably going to be easy enough to do with guess and check, so I'm just going to jump into that. Don't forget to put the equals 0. It's a common mistake. Just don't drop it off. It is still there. Got x and x here. Factors of 22 that can give you 9. Well, you don't have many factors of 22, so you have 2 and 11. Now, signs, I didn't put those in just yet. Remember, this is where you have to interpret your signs. It's also part of that guess and check process. My signs will be opposite, and I know that the greater of these products will have to be negative. So this is a 2x, this is an 11x, this is the greater, so that should be negative, and my signs are opposite. Very good. Now we are factored. At this point, you can do exactly what we did before. Apply that zero product property and solve. So we're going to have either x plus 2 equals 0 or x minus 11 is equal to 0. That means x is either a negative 2 from here or positive 11 from here. So it's not too bad as a process. You just got to take it step by step. The first thing is, before you can apply that zero product property, you have to factor your problem. And that means if you have to do a little rearranging, you do a little rearranging. Again, make sure you're in descending order, like we were for this problem. And then go through the stages where you're looking at those factoring rules. Always search for GCF first, and then determine is it 4 terms, 3 terms, or 2 terms, and what method to use from there. Let's try another problem. Let's get some board space while we're at it. All right, I'm on example 3, which says 4x squared minus 28x is equal to a negative 49. Interesting. So the first thing I notice about this problem is I'm not equal to 0. Well, inherently with the zero product property, 0 is part of the name, meaning you have to equal 0 from two products or multiple products. And so what I'm looking at here is that problem was equal to 0. The problem I had just erased was equal to 0. We didn't have to do any rearranging. For this problem, you do have to rearrange a little bit. So I'm going to move that 49 over. That gives me 4x squared minus 28x plus 49 is equal to 0. Again, don't drop that equals 0. That's a common mistake. At this point, see if you have a GCF. You don't? Okay. Do you have 2 terms, 3 terms, 4 terms? Well, you got a 3-term polynomial, so we're going to go ahead and factor this using box, guess and check, or your AC method. Any of those will be fine. However, you can also see that this is a perfect square on either end, and you could apply the definition. I'm just going to use guess and check in case you're not seeing the definition, and you'll see what I mean in just a moment. First terms here, what can give me 4x squared? How about 2x and 2x? What terms could give me 49? How about 7 and 7? My signs are the same, and they're both negative. Now, how do I know that actually works? Well, check it. This is a negative 14x. This is a negative 14x. When combined, that gives you a negative 28x. So yeah, absolutely, this works. Now, let's assume that you just go from this point where you have two identical pieces, and you say, I have 2x minus 7 is equal to 0, because I'm following that zero product property. 2x minus 7 is equal to 0. Excuse me, my throat is getting to me right now. Okay, so that being said, you know because these are identical that you're going to get an identical response. So really you only have to do this problem once, but let's go through and just see how it works. We're going to add 7, divide by 2, so x will be 7 halves. Over here you would do the same exact thing, and you get x is 7 halves. Well, does that mean I should write it twice if it's the same exact answer? No, you write it one time. X is 7 halves to make this problem equal to 0. Now, you might be saying, well, why did we get one answer there, but we got two answers there? Good question, right? I'm going to show you a little insight. These are not graphing exact problems, but just to show you what the solutions actually mean. When you have a problem that has one solution like this, what you're doing is you're actually graphing a point of intersection where your parabola will curve, touch on the axis, and continue going. So you're touching on the x-axis once. This is where you would have 0 as your value, hence the term zero product. Now, in this case, I have 2 zeros. I have 2 values that would cross, and so my parabola would cross at 2 different points, just like so. Okay, now, again, these graphs are not to scale. They are just to kind of give you a little insight as to why we're getting one solution or 2 solutions, because that is a good question. Okay, that being said, let's try another problem, which means I need board space. That was example 3. We're on example number 4. So I have x times the quantity of 2x minus 7 is equal to 4. So first things first, am I equal to 0? No. So I do need to move this 4 over, but this side, there's work to be done. So let's go ahead and multiply this and then move that 4 over. So this gives me 2x squared minus 7x. I'm going to move this 4, so that's minus 4, and I am now equal to 0. Excellent. Now, at this point, we need to do a little factoring. So let's go ahead and do that. Still equal to 0. Factors of 2x squared, I got 2x and x. Factors of 4, well, I've got 1 and 4, and I've got 2 and 2. The question is, how do I get 7? Keep in mind, you still have this term to play with. So I'm going to say, let's do 4. So if I put 4 here, 1 there, so 1 and 4 is my pair. 2 times 4 is 8. This gives me 1. So yeah, that could give me 7. Now let's check about the signs. The greater should be negative. Sorry, the signs will be opposite, and the greater should be negative. I'm jumping around on myself here. So this sign, again, the signs of the binomials should be opposite, and this sign is telling me the greater should be negative. Okay, so I have 2x and 4, that's a negative 8. Once I put that there, this gives me a positive 1, and those combined could give me a negative 7. Now, let's go ahead and apply zero product property. Jumping ahead of myself there. There we go. Simplify what you've got. So I've got x is equal to a negative 1/2 on this side. Subtract that 1, divide by 2. And I've got x is equal to 4 on my other component. Okay, very good. Let's do the last example here. Keep in mind, zero product property is something that will come up later, so you do want to get a good handle on this. Okay, example 5. So I've got 2x cubed minus 4x squared minus 30x is equal to 0. So first things first, of course, do you have a GCF? Yes, what is it? Well, everything's even, and everything has at least one x. So I'm going to pull that out as 2x. I'm left with x squared minus 2x minus 15, still equal to 0. Let's go ahead and factor. So I'm going to get this set up for my guess and check, but don't forget this 2x. So just bring it straight down. I got x. Factors of 15, I've got 1 and 15 are 5 and 3. Let's use 5 and 3. Signs will be opposite. The greater will be negative. Still equal to 0. But hey, wait a minute. I've got 3 products now. How does that work? Well, the zero product property, if you think about it, again, it's at the very top of your page. But if you think about it, the zero product property is saying A, B equals 0. It doesn't say that you're limited to A and B. What if you had A, B, C equals 0? Well, then either A is 0, B is 0, or C is 0. So zero product property can apply as long as you have products. In this case, A, B, and C. So I have 3 different products. So I'm going to take each one and set it equal to 0. And then solve. So here I get x is 0. Here I get x is 5. Here I get x is negative 3. Go least to greatest as you list them. X is either negative 3, 0, or 5. And that is it. Okay, guys, that's it for the solving quadratic equations by factoring, basically using that zero product property rule. I'll be continuing into another lecture in just a few moments or as soon as you click play.